Okay, thank you. That's forward then, is it? James Wilson, Studio Anyo Architects. We're a general architecture interior design business, but we have an MMC advisory service tacked onto it. So we do general architecture, is about 50% of our work, and then the remainder is linked to MMC approaches. So what we do is we design to allow an MMC approach to be considered throughout the project. So our projects are tendered as MMC. They get planning permission, allowing full CAT 1 volumetric all the way down to panelized, precast, LGS, all can be associated. We also advise manufacturers and do system design. We have our own patented system design. We work with manufacturers around the world on their systems design, system development. And we've currently just finished a project in Sindala, latest hotel in the Red Sea, MMC. So we've been around a while in the MMC market, and these are some of our clients. So our current workflow as architects on an MMC project is we start with a sketch. So we design all the way through to manufacturing, often with manufacturers as a part of the manufacturing process. So our digital workflow is start with a sketch, then it goes up into SketchUp or Rhino, depending on how the design develops. So that's owned by Trimble, and those SketchUp doesn't talk to anything, and Rhino doesn't talk to anything. And the versions of SketchUp and Rhino don't talk to each other. So trying to get one into the other is a very complex process, and you need an MMC just to get a master's degree to get in between the two. We then go into Revit, which as a program is probably 20 years behind where the car industry sits in terms of development of a program. It's a very clunky old program, so we do it in full BIM 360. And we put it out into an IFC that the other consultants don't use, have different versions. The other consultants refuse to go into BIM 360. And so some of us are in an IFC file. So then we get to planning, and we have to produce 2D drawings. But the visualizations of the Revit doesn't work for planning. So we need to redo the drawings from Revit back into planning set of drawings. So over the 2D, these Revit files we have to get a 2D drawing graphically, because Revit doesn't do graphics. So we have to redraw the files from the Revit into planning. Then we move on, we got to visualize it, so we go back into Rhino, but Rhino doesn't like Revit and IFC. So we have to move around all these Revit files and trying to get visualizations back out. And then once we get planning, we got to go back into Revit, and we try and coerce all the other consultants to get into Revit. And the MEP guys simply refuse normally, or they don't know what to do it, and we end up drawing the MEP drawings ourselves half the time. So that's our day job, and that's how the vast majority of our projects work, from 60-70 million pounds down to £1 million. That's very common. There's no project we work on where this digital flow actually happens correctly. So the next level of digital processing we do is pattern books. So we develop pattern books for manufacturers, and from the pattern books we create digital twins that sit to manufacturing level, and then the manufacturers use this to assemble their designs. So we've worked with a number of manufacturers to create pattern books with tied-in Revit files. The main issue with them is there's a big pushback against standardization and user product design within the industry, so it's very hard to get the pattern books straight into planning permissions. But there's quite a bit of work on pattern books in terms of moving 2D panels, so we did a similar exercise for Glenveagh with 3D panel work. So that's the second digital flow, would be pattern books back into planning permissions. The third workflow we do is automation, optimization AI tools. So we take the pattern books, we've worked with Prism, Creo, and a few more optimizations. So we create the pattern book, we give it to an AI tool, and they try and create the optimization layouts. All these tools are really in their infancy, and the biggest problem with them, they don't produce or allow enough design flexibility or design development through the digital flow. They are tied to live BIM models, live BIM sets, so there is interconnection in the tools, but the actual design abilities and the flexibility and the process of design that these tools are doing are very crude, so they can't really achieve the kind of usability that like SketchUp and these type of tools use. So there's still a long way to go in the optimizations tools, but these are all being developed in parallel. So you've got the current digital workflow, which is very cumbersome and very difficult to manage. So there's a lot of stop points, changing files in our basic workflow. The pattern books are coming along, and there is some success with pattern book development. And then we're working on the AI digital workflows as well. But again, it's still early doors. I think we're very much at the first stage of this digital revolution. So rather than anyway, at the coal face anyway, there's a long way to go before it comes anywhere near the kind of integration that's needed. So I'm going to show you some of the workflows we normally do. So we do very advanced modeling. So we've got advanced 3D modeling. So this is one we've just done with Imperial College. So we've taken the central landscaping, and we've had to move that into their full BIM standards. So even the latest version of Revit can't manage curves. So all these curves and 3D visualizations that you see here, trying to get these into a Revit model, which is a very cumbersome 2D modeling software, is extremely difficult. And even the latest solid versions of Revit find it very difficult. And to move that back into planning drawings then it's extremely complicated. So we're moving from Rhino straight into a Revit model for planning, but back out into a SketchUp software to visualize. So it has to move through 3 sections very quickly, and that's extremely complicated, particularly when you're using 3D forms like this and the edges of slab. Back into a verification model, full BIM standards for Imperial College. So this is all fully BIM coordinated back into a full model. Then the architects need to take these drawings back into planning drawings, but they've basically had to do 2D modeling on top of them. So again, it's a very difficult workflow. So it's very hard to realize the actual true nature of how you're actually doing it at the coal face. So this is a pattern book we've just created for Rapid Builder Ukraine. So this takes a volumetric apartment system. It codes it back into a full BIM model. So there's a BIM model tied behind this. And the idea is you publish the full pattern book to architects and to manufacturers, so allows rapid deployment of accommodation throughout Ukraine through a standardized layout. It's fully compliant with all the codes in Ukraine, and it's fully designed to the ground conditions and all the regulatory requirements in Ukraine. So it'll be a fully signed off system that you can just build, and you'll be given the full tech Revit model to work with. So basically, this system allows for multiple stacking. So stacking 1 bed on top of 2 bed. It's got click and connect technology in it. So when it comes down, it clicks together and connects, and it can create many different plan forms and variations to allow multiple mixes of apartments to be deployed in a volumetric fashion. So you see you can get a templated apartment block fully ready, and you give that to manufacturing partners with a fully detailed construction, and you've got multiple stack options, multiple variations of 1, 2, 3 beds to the 1 bed stack on top of it, 3 beds, etc. This and full service integration. So the idea is you can rapidly rebuild Ukraine with these apartment typologies, and the technology is manufactured locally. Then the facade options can be applied. So with the click and connect technology in the facade's watertight. Once it's created, and you can apply a rain screen type facade on the top of it to create local vernacular variations. These are some we've done with similar technology, have applied rain screens. And these are some of the apartment blocks that's using the similar typologies in the UK that are being completed. One with Paul. So from the pattern books, which allows rapid deployment of standardization apartments, this one is working with an AI software. And this takes the pattern book into an AI optimization software and allows the software to create optimized solutions using the pattern books. So, and this is also attempting to allow the architects some degree of design. So the problem with a lot of the AI softwares at the moment is they're trying to control the design aspects, which doesn't allow the contextual design of the units. So what we've been trying to focus on is allowing design variation and non-standard adoption for sites. But tied to this pattern book is a fully costed model, so we have manufacturing level costings and data tied to the unit. So as you're doing your massing and as you're doing your design, you can control costs, program, change the finishes, and manage those aspects through the model. And it creates significant number of variations, so you can test it. It also links to thermal software, and then some of the ones in the UK now are linking to View Cities, or linking to the planning. This one can also slot into the planning models. So in the UK they have built citywide models that the planners use. And you can drop these models into them, so in your planning meetings, these models can drop in and relate to the bigger planning stories. But kind of the key takeaway is these softwares and these integrations are still very much in the early adoption stages, and there's a significant amount of work to be done before they can be integrated into architectural workflows, and consultants actually all working together in the BIM models, and not everybody having to redraw it at each stage. So hopefully AI will bring that on and start pushing on BIM integration so that the workflows can be continuous.